This is Senior Algebra, Section 3.4, Equations and Graphing. So today we're going to be given some information, sometimes some slopes, sometimes some y-intercepts, doing some graphing with that. So let's review the forms that we've looked at here a little bit. Standard form, a couple things we're going to add here. So it's ax plus by equals c. A, b, and c are integers, which means that no fractions here. Notice the little bit at the end there, a, b, and c are integers, and a is greater than 0, b cannot be 0. So a has to be positive, b cannot be 0. An example, 3x minus 2y is 5. 3, negative 2, 5, they're all integers, 3 is positive. If we had 1/2 x plus 5y equals 7, we couldn't write that, that's not considered standard form, simply because of the 1/2 there. We would have to multiply by 2. When I multiplied by 2, I would get rid of the fraction there. So I'd end up with x plus 10y equals 14. That would be considered in standard form. The next one, slope-intercept form. We're going to look at two different ways. One, y equals a plus bx. B is your slope, A is your y-intercept. You may have also seen it in the form y equals mx plus b. Either one is fine to use for me. You should be familiar with that and know that what? The slope is next to the x, the b or the a, the y-intercept, is the other number. And what do we know? To get it in slope-intercept form, we have to get the y alone here. The next one, point-slope form. That's y minus y1, b, which is the slope, x minus x1. y1 and x1 are just a point. It's an x-coordinate on a point and a y-coordinate for a point. So if I was given a slope and a point, I could write an equation for that. And then the last one, if you looked at the slope formula, b equals y2 minus y1 over x2 minus x1. Remember slope, the change in y over the change in x here. How do I find how much things are changing? How much does it change from 10 to 12? Well, it changed 2. I could subtract that. So in example 1, says we want to find an equation of the line with a slope of 2/3 and a y-intercept of 0, negative 3, or 0, negative 1. So we're going to write it in slope-intercept form because that's what we're given. Negative 1 plus 2/3 x. In example 2, we're looking to graph that line. Now, right now it's in standard form. Okay, the problem with standard form is it's hard to graph in standard form. Usually when we graph, we want to get it into slope-intercept form. So to get in slope-intercept form, I'm going to get the y alone. I should move the 2x over, divide by negative 3. 3 divided by negative 3 is a negative 1. And then negative 2 divided by a negative 3. So a negative and negative gives you a positive there. So I'm going to get a positive 2/3 x. So now to graph it here. In order to graph, I need a couple points here. One of the points is my y-intercept. Remember, what's the coordinate? 0, negative 1. So my y-intercept is going to be at negative 1. And now to find my other point, or another couple of points, I'm going to use the slope. Remember, slope, rise over run, the change in y over the change in x. If the slope is 2/3, that means I'm going up 2 over 3, and to the right, I'm going to say, because right is positive. Up 2 is a positive, right 3 is positive. So I go up 2 over 3. I could go down 2, that's a negative, and to the left, which is a negative, because a negative and negative will still give me a positive slope. Remember, everything should be in a straight line there. If I had a point that was off, I could say that, yep, I know I made a mistake there. In example 3, so we're given the point now, negative 2, 4, and a slope of negative 3. We're going to graph it first, and then from the graph, we're going to come up with an equation. So we start negative 2, 4 is there. a slope of negative 3. I'm going to make that a fraction. So that's negative 3 over 1. Now I could go down 3 to the right 1. Right is positive. Down 3, which is a negative. To the right is positive. Negative over a positive. I could have also went up 3, a positive 3, and to the left, a negative 1. That would have been fine too. Now I want to write it in slope-intercept form. That's what, y equals a plus bx. So I need my a, my b. My a is my y-intercept, my b is my slope. Nice thing, they already give us a slope. Slope is negative 3. Now we have to find the y-intercept. Well, we look at the graph. If I look at the graph for my y-intercept, where is it crossing? It crosses at negative 2. So my equation y equals negative 2 plus negative 3x. If you wanted to write it y equals negative 2 minus 3x, that would be fine too. And our last example, example 4 here. We're given the point negative 2, 4, slope of negative 3. And we're going to write this in slope-intercept form using algebra here. So I have two methods here. Which one you use is up to you. I'm going to show you both. The first method, I was going to use slope-intercept form. So remember, slope-intercept form y equals a plus bx. I have a point, and I have the slope. So I need to figure out what my a is. Now my slope is negative 3. I know that goes there. And my a is there. That's what I'm looking for. But I have to have an x and a y here. So I know that x and y works in that equation. So I'm going to plug it in and find what a is. When I solve for a is negative 2. Now remember, a was what? My y-intercept. So it asked me to write it in slope-intercept form. So I have the slope, I have the y-intercept. It's going to be y equals negative 2 plus negative 3x, or again, minus 3x. Same problem that we did in example 3. In example 3, we did it geometrically with a graph. In this one, we did it algebraically. But we come up with the same equation. So method 2, we're going to use point slope form. Remember point slope form, y minus y1 equals b, x minus x1. The y1 and the x1 are simply the coordinates of a point, and my b is my slope. So I'm going to plug in my points here. y1 is 4, y minus 4, b is negative 3, x minus negative, I'm going to put it in parentheses because it's a negative 2. Minus a negative is really plus. So I have y minus 4. I change x minus negative 2 to plus 2. And then I'm going to distribute negative 3x plus 6. At this point, it's not in slope-intercept form yet. I have to get the y alone. So I'm going to add 4 to both sides. And I get y equals negative 3x minus 2. Same thing, written just a little bit differently, but the same thing that we found in that one. So 3 different ways. 1 graphically, which we looked at in example 3, and 2 algebraically. Which one you use algebraically is up to you.